Well, in question number 19, we have to integrate this function sin inverse root x minus cos inverse root x upon sin inverse root x plus cos inverse root x, and it is given that x belongs to 0 to 1, that is closed interval 0 to 1. Okay. Now, first of all, why this interval is given, let us see. We know that if sin inverse x is given to us, its domain is minus 1 to 1. Okay. And here sin root x is given. So negative values are not applicable, both for sin inverse x and cos inverse x, and both have that domain as minus 1 to 1. Okay. So cos inverse root x also have the same domain. Okay. So x is only applicable for positive values, so that is why this domain is given to us. Okay. Next thing which has to be noted is this, that sin inverse root x plus cos inverse root x is equal to pi by 2. Okay, pi upon 2. So this formula is useful to us because denominator get reduced to a constant value, and secondly, instead of sin inverse root x, I am going to write pi by 2 minus sin inverse of minus cos inverse of root x, cos inverse of root x. So I am going to get this as pi by 2 minus 2 cos inverse of root x whole upon pi by 2 dx. On dividing it individually, this will be equal to 1 minus 4 upon pi cos inverse of root x dx. Okay, so now we have to integrate this instead of the original integral which was given to us. Okay, so this will be equal to this. Straight away we can write that it is equal to x minus 4 upon pi cos inverse of root x dx. Okay, so now we are left to integrate cos inverse root x. Okay, so to integrate cos inverse root x, I assume that I1 is equal to cos inverse root x. After integrating cos inverse root x, I am going to substitute its value, simplify it to get the answer. So to integrate this, I am going to place root x is equal to t, or x is equal to t square, or dx is equal to 2t dt. Okay, so I am going to get I1 as equal to cos inverse of t into 2 t dt. Okay, now I am going to apply the formula of integration by parts. So this will be equal to twice cos inverse of t into t square upon 2 minus minus d upon dx of cos inverse of t into integration of t and whole integration. Okay, so this will be equal to t square cos inverse of t, on multiplying it by 2. This will be equal to minus differentiation of cos inverse t is equal to minus 1 upon under root of 1 minus t square. So minus minus will become plus. This will be equal to t square upon 2. Here 2 is going to multiply. So this will be equal to only integration of t square upon under root of 1 minus t square. Okay, so I1 is equal to this much. Further, to integrate this value, what I am going to do, t square cos inverse of t remains as it is. I am going to subtract 1 and add 1 and do it, and the denominator remains as it is. Okay, now I am going to divide them individually. So I am going to get t square cos inverse of t plus t square minus 1 upon under root of 1 minus t square plus 1 upon under root of 1 minus t square dt. Okay, so I1 will be equal to t square cos inverse of t minus under root of 1 minus t square dt plus integration of under root of 1 minus t square dt. Here we should know this, that we have been given t square minus 1 upon under root of 1 minus t square. So this will be equal to 1 minus t square upon under root of 1 minus t square. So this will be equal to minus of under root of 1 minus t square. Okay. So I1 will be equal to t square cos inverse of t. On applying the formula, this will be equal to minus of 1 by 2 t under root of 1 minus t square plus 1 upon 2 sine inverse of t plus sine inverse of t. Okay. Further on solving, I am going to get t square cos inverse of t minus 1 upon t under root of 1 minus t square. This is minus 1 upon 2 sine inverse of t plus sine inverse of t. So this is going to become plus 1 upon 2 sine inverse of t. Okay. So on placing t as equal to root x, I'm going to, or t square is equal to x wherever applicable. So I'm going to get this as x cos inverse of root x minus 1 by 2 x into under root of 1 minus x plus 1 by 2 sine inverse of root x. Okay. So this is the value of I1 which we obtained after integration. Therefore, x minus 4 upon 5 cos inverse root x dx will be equal to x minus 4 upon pi x cos inverse root x minus 1 by 2. This x, here it was root x into under root of 1 minus x. Okay, so this is going to become x minus x square plus 1 by 2 sine inverse of root x. Okay, so I have substituted the value of I1, that is integration of cos inverse root x, and this is what I obtained. Okay, further now I am going to multiply this 4 upon pi to all these terms. So I am going to get this as 4 x upon pi cos inverse x, cos inverse of root x minus plus 2 upon pi under root of x minus x square minus 2 upon pi, again 2 upon pi sine inverse of root x. Okay. Okay, this term will remain as it is. Now I'm going, and we have now cos inverse root x and sine inverse root x. So I'm going to convert this cos inverse root x into sine inverse root x by applying this formula. 4x upon pi will remain as it is by writing cos inverse root x as pi by 2 minus sine inverse of root x. Okay. And minus 2 upon pi sine inverse of root x is written here, and plus 2 upon pi under root of x minus x square is written here. Okay. Now I'm going to multiply x, so I'm going to get this as x minus 2x minus 4 minus plus 4x upon pi sine inverse x minus 2 upon pi sine inverse of root x, here it is root x, plus 2 upon pi under root of x minus x square. Okay, so we are going to get this as minus x. From here we can take x as 2 upon pi as common. 2 upon pi as common. Sine inverse x can be taken as common, so I'm going to get this as 2x minus 1, okay, plus 2 upon pi under root of x minus x square. So this is our final answer after simplification. Okay, well, in this question a silly mistake has been committed, and here it was d upon dt of cos inverse t, okay, not d upon dx. Okay, so sorry for that.